Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Farel praya ampel. Today, I'm going to explain about chemistry in geologic process. Before I start the presentation, I'm going to explain about relation between basic chemistry and geological process and why is chemistry important. Fundamental chemistry is intrinsically linked to geology, as both fields work together to enhance your understanding of the various processes occurring on Earth. Chemistry elucidates the composition and properties of Earth's material, including, including minerals, rocks, and geological fluids. A significant aspect of this relationship is seen in geochemistry, a scientific discipline that investigates the distribution and behavior of chemical elements within the Earth's crust, mantle, and core. Through chemical analysis, researchers can date rocks using isotopes, examine safe in, is safe in mineral composition during geological events, and gain insight into the age of various rock formation. Process in geologic hits have a two point, maturing in erosion and mineral formation. For the first point, maturing and erosion. Watering and erosion are two interconnected natural processes that play a crucial role in shaping the Earth's surface. Watering is the process of breaking down rocks, soil, and minerals into smaller pieces through physical, chemical, or biological mechanisms. This process occurs at the original location of the rocks without any movement of the material. For example, physical weathering happens when rock crack and break due to freezing and thawing weather of extreme temperature change, while chemical weathering involves change in the chemical compositions of rocks, such as limestone dissolving in acidic rainwater. Additionally, biological watering involves living organisms, such as plants' roots breaking apart rock structures, oscillations producing acids that dissolve rocks. On the other hand, erosion refers to the process of the transporting into materials resulting from watering from the one place to another through natural agents like water, wind, ice, or gravity. Unlike watering, which only breaks rocks into smaller places, erosion involves the movement of these materials, leading to significant change in the landscape. For instance, fast-flowing rivers can erode soil and rocks along their paths, carving out valleys, while strong winds can carry sand particles, forming a sand dunes. Erosion caused by ice typically occurs in snowy regions where glaciers slowly move and carry rocks and soil, whereas gravity can cause landslide or the fall of large rocks from cliffs. Together, weathering and erosion are integral components of the Earth's geological cycle, playing a significant role in shaping the plane surface, contributing to the formation of a wide variety of landforms, and influencing the development of ecosystems. This process, the process are responsible for transforming once ridge towering mountain range into more gradual rolling hills, creating new landscape over long periods. Top weathering rocks are broken down into smaller particles, which over time can carried away by the forces of erosion. Erosion itself transports these fragments, whether they are pieces of rocks, mineral particles, or organic matter towards lower elevation. As this material accumulates, they form deposits that, that gradually build up into fertile plains, valley, and other rich landscape that sustain biodiversity. These processes are also responsible for the formation of iconic natural landmarks like Cancer, Rifle Valley, Arcades, and Coastal Lake Cliffs. All of landmarks, all of landmarks like Kansas, river valleys, which are the result of millions of years of continuous geological activity. These breathtaking features tell the story of the Earth's dynamic nature and inconstant transformation. Beyond their enslaving of landscape, weathering and erosion critical information of soil, which is plants in the ecosystem that depend on it. As rock undergoes weathering, they break into smaller particles, combine with organic material such as the decaying plant and animals to form soil. This process creates the fertile groundwork necessary for agriculture, allowing for the growth of the crops and the sunset of the plant-based ecosystem. This in the water, rocks presence also provides habitat and nutrition of countless organisms, contributing to the rich biodiversity they were really on. Mineral formation. The formation of metallic minerals through the cooling and solidification of magma is known as the magma differentiation process. This process occurs as magma cools or its temperature decreases, leading to the development of various types of igneous rocks. Each type of igneous rocks is defined by its specific mineral composition, which depend on the initial composition of the magma and the temperature of which its sol- soldates. Through magma differentiation, the mineral composition of igneous rocks and include a combination of metallics and non-metallic minerals. This polarization arises from the interaction between the magma chemical properties and environmental conditions during cooling. Additionally, certain cooling process and the original composition of the magma can result in the consortium of the economically valuable mineral deposits, often referred to as mineral traps. This deposit record contain essential material like gold, silver, and nickel, which are crucial for an economic purpose. In essence, the magma differentiation process not only generates operates of the igneous rocks, but also calculates of the formation its mineral rich deposit, significantly contributing of Earth's contributing to Earth's geological and economic growth. Metamorphism change in the rocks due to heat and pressure. Its have a trick point. The one point is heat. The Earth's interior is a dynamic environment where heat and pressure play a critical role in the formation of rocks. One significant process that occurs under these conditions is metamorphism, during which existing mineral within rocks breaks quality and transforms into new minerals. This process is essential for understanding the geological evolution of the Earth and the formation of the metamorphic rock. The point 2. Pressure. Pressure is a fundamental factor in the metamorphic process, significantly influencing the texture and composition of rocks. When rocks are subject to the immense pressure from the flowing materials of the tectonic forks, the minerals within them can undergo rearrangement, leading to the formation of the metamorph rocks with distinct characteristics. The point 3. Fluids. Fluids suck water and carry dissolved mineral that reach with extra mineral in the rocks, causing change in the composition and texture. Rock cycle. The rock cycle is A true point. Igneous rock are type of rock that forms from the cooling and solidification of multi-material called magma beneath the Earth's surface or lava when it erupts on the surface. Sedimentary rock. Sedimentary rock are formed through accumulation, compaction, and fermentation of sediment over time. These sediments can be fragments of the rocks, mineral, organic material, or chemical precipitates. Metamorphic rocks. Metamorphic rocks are formed when existing rocks, or e- either igneous, sedimentary, or other metamorphic rocks, undergo metamorphismal process of transformation due to high pressure, temperature, or chemical process within the earth. Igneous rock. Igneous rock are a category of rocks that from the cooling and sedimentation of molten material, snow, ex magma beneath of the earth's surface or lava is around on the surface. These rocks form a compound of minerals that crystallizes from the cooling of magma, and their characteristics of mineral composition, texture, and appearance depend on conditions under which the magma cooled and solidifies. Formation of igneous rock. 1. Cooling of magma or lava when magma molten rock beneath the earth's surface. Cooling and solidifies a forms igneous rock if the magma cools slowly beneath the earth's surface. As a result, it cores grainy rocks with large crystals. If lava cools quickly on the surface, the resulting often graphite with small crystals. Point 2. Mineral crystallization. As the magma cools, mineral begins of crystallization at different temperature. The first mineral of crystallization the first mineral to crystallization are typical loose that are rich in iron, magnesium, and calcium, such as olivine and pyroxene. As cooling contains lighter minerals like feldspar, quartz, and mica maze crystallization. Sedimentary rocks. Sedimentary rocks are type of rocks fundamental rock accumulation, compaction, and commencement of the time. The sedimentary rock typically derive from the weathering and depression of for existing rocks, along with organic material, chemistry, precipitates. Sedimentary rocks are important of understanding Earth history because they often contain fossil and prophets called about volcanoes, mechanism, and geologic activity. Formation of sedimentary rocks. 1. Weathering and erosion. Sedimentary rocks bend deformation with the blocks of existing rocks, igneous, metamorphic, or other sedimentary rocks. Through weather processing, physical weathering, age when water ice, and and chemical weathering, age oxidation, dissolution, break down the rocks into smaller particles, soaks, and mold or clay. 2. Transportation and deposition. The smaller particles are transported by engines such as rivers, wide glaciers of ocean currents to new location where they are deposited. Over time, the accumulation of the sediments can form layers in environments like rivers, deserts, oceans, and lakes. 3. Composition and compaction and condensation. As additional layer is sediment accumulates on top of each other, the lower layer experiences increasing pressure, causing the particle to compact. Mineral dissolved in water then acts as a natural glue, cementing the particle together to form solid rock. This process is known as lithification. Metamorphic rocks. Metamorphic rocks are a type of rocks that forms with pre-existing rock, igneous, sedimentary, or other metamorphic rocks, undergo a transformation due to high pressure, temperature, and chemical process within in the earth. This transformation known as metamorphism alters material composition, texture, and structure of the original rocks. Without the rock actually melting, the result is a new type of rocks that have different physical and chemical properties from the original. From the of material from the Metamorphic rocks. Metamorphic rocks are formed deep within the Earth's crust, where height, pressure, and temperature conditions prevail. This condition causes the mineral in the original rocks. This requires delays from the new mineral that are stable under the new conditions. 1. Pressure. Pressure can come from the weights of the overlying rocks layer or from tectonic forces. Our rocks are subject to compression. This, this pressure can cause the mineral in the original rocks to become more compact, often leading to the same texture. Temperature. As from the Earth's endurance, solely from nervous magma or from the glacial garage, perfect energy needed to metamorphism. The higher the temperature, the more likely is that mineral will recrystallize and from the minerals that are stable at high temperature. 3. Chemical fluids. In some cases, the presence of chemical active fluids can accelerate the metamorphic process. These fluids can derive from water or gases and facilitates the migration of ions, leading to the formation of new minerals. Igneous process. The formation of volcanic and plutonic rocks. 1. Magma formation. Magma is molten material that from within the Earth's implied course of geologic process, including the formation of volcans and the creation of rocks. The process of rock formation involves several factors related to conditions inside the Earth, preserved in the mantle and the Earth's core. 2. Cooling and crystallization. As magma rises toward the Earth's surface, its undergoing a cooling process is essential for the formation of igneous rocks. The formation from molten material to solid rocks in the physical factor, including the rate of cooling and the chemical composition of the magma is still. Volcanic and plutonic. Rocks formed for volcanic and plutonic as ancestral composition of the Earth's crust, which the karst and formation informants. Understanding the difference between these two types of igneous rock provides its insight to geological process and the history of application of chemistry in the resource completion, exploration, and environmental studies. 1. Resource exploration. Chemistry plays a crucial role in defending potential mineral deposits and hydrocarbon reserve. Chemistry aligns the chemical composition of rocks, soils, and fluids to independent areas where these resources are likely to be found. 2. Environmental studies. Chemistry use their expresses of the as important of impacts of pollution on the environment, study of movements and contaminants in groundwater, and develops strategies of strategies for environmental remediation. That's my presentation about chemical in geologic process. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.